Hello friends, welcome to Electronic Circuit Hub. So today we're going to understand about the level shifter design. We will understand the common base level shifter design. We will also understand the common gate level shifter design. Okay, we will understand the difference between common base level shifter design and common gate level shifter design. Okay, so let us first understand the common base level shifter design. So you can see here, this is very simple circuit, and what I'm gonna do is here I want to convert the 3.3 logic level to 5 volt. Okay, so my objective here is to convert the 3.3 logic level to 5 volt. So in order to do that, I am using one NPN transistor. You can see, so this is basically a NPN transistor, and you can see the emitter of this NPN transistor is connected to a pulse source. So you can see here the pulse source is 3.3 volt and T on is 0.5 millisecond, T period is 1 millisecond. That means this emitter is connected with 1 kilohertz frequency with amplitude of 3.3 volt. Okay, now you can see here guys, this base of this NPN transistor is connected with base resistance R3, that is 4.7k, and now you can see from this resistance I have connected one DC voltage. Okay, so the amplitude for this DC voltage is 3.3 volt. Okay, so you can see this side we have 3.3 volt DC, and we have here the 3.3 volt pulsating DC with the frequency of 1 kilohertz. And do not forget to connect this pull-up resistance. This is very important, otherwise this circuit won't work. So I have connected here, you can see this pull-up resistance R2 between this point, the resistance R3, and you can see the emitter of NPN transistor, the emitter of Q2. Okay, and you see here now at the collector I have connected one more resistance R1, and that is going to be connect here the V3. Okay, so at this point of time the value of this V3 is, you can see here, the 5 volt. Okay, so here I have connected the I have just pulled up the collector with the voltage of 5 volt, and the pull-up resistance value is 4.7k. so you can see all the three resistance here I have connected to the 4.7k. You can connect any other value, but this is the reasonable value you can connect, because 5 volt divided by 4.7k, it will draw at most around 1 milliampere current, right? So for the common gate, you can see here, this is CV. I called this CV for common base level shifter, and for the common gate level shifter I called here is CG. What is the difference between common base level shifter and common gate level shifter is, you can see, in spite of using the NPN transistor here, I have used N channel MOSFET. So only the difference between this common base level shifter and common gate level shifter is, in spite of using NPN transistor Q2, here I have used N channel MOSFET. If you use a MOSFET in spite of transistor, you will have many advantages. Okay, now what I'm gonna do is, I'm gonna directly run the simulation. I'll show you the waveforms here. Okay, so in order to run the simulation, you have to go the simulate button, edit simulation command. You can see here the stop time is 50 millisecond. Okay, for this, and the stop time is 50 millisecond for this. Okay, so now go at this button, this is run button, click on the run button, and let me show you first this voltage. Okay, let me do tile window vertically maybe, and let me add two plot pane, one for common base and one for common gate. Okay, so this is 3 volt. At this point you can see this is 3 volt, some ripple. At this point you can see the 3 volt here also. It's not pretty good because it has having some ripple in the millivolt. Okay, now at this point of time I'm gonna show you the voltage here. You can see this is your, what is this? this is your the pulsating DC voltage with the frequency of 1 kilohertz. Now I'm gonna show you the voltage at this point, and you can see both voltage looks like same, more or less same. 1 kilohertz frequency with the amplitude of 3.3 volt. Okay, now you can see the output voltage here. Okay, so let me show you first the output voltage for common base level shifter. Okay, so you can see this is the output voltage for common base. You can see VCB. Let me show you the output voltage for common gate. This is VCG. Okay, now you can see your red is VCG, the output voltage for common gate, and this is VCB, the output voltage for common base. What you can see is the amplitude of both common gate and common base are same. Okay, so you can see this is 5 volt here. Okay, this is 5 volt, and if I add cursor here, I can see here 5 volt. So you can see you are shifting your 3.3 logic level to 5 volt. If you use common base configuration, you can see here VCB, and if you use common gate configuration, even though you are shifting your 3.3 logic level to 5 volt in the red color. Now what I'm gonna do is I delete this pane and let me overlap the signal here for common gate. Okay, so in this window you can see your VCB. Let me change the color for VCB. Let us assume it is red. So this time your VCB is red and your VCG in blue. Okay, so I have just overlapped the output signal for common base and the output signal for the common gate, right? And let me zoom it. Okay, and let me show you some differences here. What is the differences here? Okay, so now you can see this VCB, this is common base. This signal is rising like that. You see some edges here, and then you see it rolls up. And in the case of common gate, you can see it has some more rise time. If you compare the rise time of common base to common gate, you can see the common gate having more rise time other than the common base. Okay, this is all about the rise time. Let me show you what is happening during the fall time. Let me show you. Okay, so just zoom. Now you can see how the signal looks like. In the common base, you can see during the falling edge of the signal, this is the falling edge of the signal, and what happens is you can see your signal come down at this level at 1.9 volt, then again it rose up to 4.1 volt. That means if you're using some logic level signal, it can consider this signal to again high level. Okay, so now it has come down. While what happened in the common base configuration, you see here your blue signal is come down, then it has sharp rise at this point, and again it has some fall time and come down. So you can see some differences. If you look at the whole picture, you cannot find, but if you zoom, you can see the differences in the common base output and common gate output. So I hope guys you are now able to understand the common base level shifter design and common gate level shifter design. What is the difference between common base level shifter design and what is the common gate level shifter design? Okay, if you have any further question on this particular topic, feel free to ask me in comment section. I'll happy to reply you and I'll happy to help you. Thank you so much for watching this.